All right. Yeah. Zoom on in. All right. Switch this over. All right. So we're going to be doing section 1.2 today. It's functions and graphs. So a function is a correspondence between a first set, which we call the domain, and a second set called the range. Sometimes you'll see the functions drawn like this. So here we're going to have some domain. It's going to move it to some range. Your book gives lots of examples. And so we might go over one or two of them. So a function, and so it goes like this, and so it just one thing goes to one thing. Actually, one thing can go to the same thing. That's okay too. So a function's allowed to do this. So exactly one member of the range. So functions don't necessarily have to be between sets of numbers or sets of numbers. You can have functions between like people and things. It doesn't matter. So what are some functions you guys occur in everyday life? What are some functions that you guys deal with? Let me give you one. Let me give you an easy one. So your wage is a function of your hourly rate times time, right? So most of you work, unless you guys are on salary. Some of you might be salary, but most of you are probably working an hourly job at this point in your life, right? I did. I worked Pizza Hut when I went to school. Get paid. And so here's so the function is it takes in your rate's fixed, right? So usually it's about, I don't know, let's just say $10 an hour just to be easy, right? And say you work a 40-hour week. So your wage, so the function inputs, so here, so your wage is respect to time, inputs time and outputs how much you get paid. So if you input $40 or 40 hours, you're going to get paid $400. And so for that week. And so just, so that's a function. What other functions do you guys encounter throughout your day-to-day lives? Anyone think of any other functions? Grades? Yeah, grades. I guess that's a kind of an odd function because it has multiple, you take in multiple inputs, but you still get a single output of what percentage you did, right? So grades is definitely one. Driving, distance, distance time, right? So here's the distance formula. It's usually written in time. So you have your speed times time. This is assuming your speed's fixed, right? So say I'm driving 50 miles per hour. And I go for 3 hours. How many miles have I driven? Well, I've driven 150 miles, right? And you can just tell the officer, he's like, well, I don't know how to do variable functions. Well, I was just driving 50 miles in the residential area. It's fine, right? So yeah, so these are types of functions you see in daily life, like temperature is a function of time. So as the day goes, the temperature goes up and down and all this other stuff. There's two ways of we represent a function. One of them is this cute little machine. So we have the function machine. I don't know if you guys have seen this before, where it inputs a value x and it outputs a value f of x. So x goes in, the function operates on it, it comes out. I'll actually show you this in detail. Another one is here you have two sets of numbers, and so we'll do real numbers here. The symbol here means real numbers. We'll actually go over this in the just-in-time stuff. This is the real number. And so here you can take something from here over to here. And so this is the other function. So these are just visual representations of functions. It's not super important. It's just what it is. But let's actually do a here. So express, so given a function, x squared plus 2, we want to express how fx has an express in words how this is an x. So let's kind of express this in words. So the function takes a number. So it takes a number, squares it, then adds 2. Okay, so if you're going to tell your friend how to do a function, this is what you would say to him, right? It says take a number, square it, and then add 2. So that's what this function would be. To evaluate a function, so here if we have f of 3, everywhere we see x in this, we're going to input a 3 in parentheses. So here f of minus 3 equals 2. So here we just do this. So negative 3 times negative 3 is a positive 9. So we 9 plus 2. So this is equal to 11. F of 0, here we can just plug in 0 squared plus 2. Well, 0 squared is 0 plus 2. So this is just 2. F of the square root of 7. Everywhere we see x up here, we're going to plug in the square root of 7. We're going to square that. And we're going to add 2. So square root of 7 times square root of 7 is indeed just 7 plus 2, so that gives us 9. All right, so state the domain and range. And so the domain is all values of x, which is allowed. And in this case, the domain is all the values, right? You can put in anything you want here, right? So we just say that's all real values. Because there's not a value I can put in here which breaks the function. I'll show you one that does, and I'll explain why it does. Can you explain the formula using the wage example? Sure, I can do that. Let me finish this and I'll go through that. The range is the values I can reach. So these are the values I can reach. So here, I can reach any value above, well, this squaring, well, this guarantees that it's positive, right? This has to be a positive number. This can either be 0 or positive. You take a number, the lowest it can be is 0, and it can be any number above that, right? Because if I wanted this to be 25, I just put in the square root of 25, which is 5. If I wanted to be 3,652, I put in the square root of 3,152 squared, gives me back 3,000, whatever I just said, I forgot. 762, I think. And then I'll add 2 to it. So notice that this is at lowest can be 0. This is always 2. So the lowest number I can actually hit is 2. Can I actually hit it? Yes. And so that's why we use the bracket. It means includes that number. And then I go all the way to infinity. And we put this means I don't include infinity. We actually can't hit infinity, but we just say that. So here, the domain is all real numbers. The range is from 2 to infinity. I can't read the writing about the domain. It's all the x which is allowed. Oh, thanks for, yeah, the domain is all of x which is allowed. In this case, it's all real, or if you wanted to write it in interval notation. Okay. All right, so going back to the function for the wage. So if we did this, so here if I input how much time, I put it into the little function module, right? I'm going to output my pay. And to write it as this, so if my wage was to be 10 times t, because that's what I said, I make $10 an hour, right? And I can even put that as dollars, right? So this is actually, if I was writing it correctly, it'd be $10 t. And so if I plug in W of 40, this would be $10 times 40. And so here I just multiply 10 times 40. So my wage is W of 40 equals, oops, I don't need the parentheses anymore, $400. Okay. All right, so that's how this all looks. So let's get into the next thing. All right, so a vertical line test. So in order to tell if something's a function just by looking at a graph, So a curve in a coordinate plane is a function if and only if no vertical lines intersects the curve more than once. And so we're going to sketch something that does pass and something fails it. So here, if I have some function that looks like this, notice, and I'll go ahead and just use a different color for fun. Let's use this one. Can I have my other color, please? Yeah, it's going to be that way. So here, if I wander through with this, it's not dark enough. Let's make this color darker. I want it darker. Thank you. Here, if I wander through this line, notice here, if any vertical line, I'll only hit this function at only once. So I hit it here, here, I pass it once, here, I pass it once. So something that fails this, let's go back to black. So let's pretend I have something goes like this. So here's some curve in space. So I want to test if this is a vertical line. You don't have to use colors. I'm going to use colors, but when you write up the notes. So here, I hit it once, that's fine. But here, if I wander through this vertical line, in fact, let's make it a very clear vertical line because that's not that vertical. I hit it once, I hit it twice, and in fact, I hit it 3 times. And so this right here fails, right? It fails the vertical line test. And if one line fails, if one line fails, it's enough to say it's not a function. Okay. So as long as if one vertical line breaks it, it completely fails, we say, well, that's not a function. Okay, so not all equations are functions. This is important to know. Not all equations will be functions. And so let me actually show you an example of that. So here is an equation of a circle. And technically, we should know how to graph this at this point, right? Hopefully. Do you have to write down every single thing you write on the notes? No. Write your own notes, per se. So when I write out words, you don't have to write them out. You should have it filled out, though. So if I make a marking in, let me see if I can say this correctly. You should have these 2 pictures. You should have this picture and this picture drawn out with a couple sample lines. Yes. Do you need to have this? No. Let's go back to the first page. You should have this, like, this should be written out. This should be written out. These should be here. You don't necessarily have to have this. If you write just the domain is all reals and the range is this, that's fine. So you don't actually have to write out the words, but if we do math, write down the math, okay? So it's just fill out the notes. And if I say something that I don't write down, you want to write it on your notes, write them down. The notes are for you, but they do need to be complete. Does that make sense? Okay. All right, guys. So for here on example 5, what's the center of this circle? What's the center here? And what's the radius? So the center is at 1, 0, which is correct. So it's going to be at 1, 0. And the radius here? Write down the formula real quick. Plus y minus k squared equals r squared. Okay, so a lot of people are saying 9. So is 9 squared equal to 3? Square root of 3. Okay, so just be careful. Be careful with that. That's why I literally put this on the next page of notes, is to say, hi, do you remember? But it's also to teach another theory. So I can do, so here it's a square root of 3. Square root of 3 is a little over 1. It's actually closer to 2. So here square root of 3 would be a little bit closer to 2. So here I just mark that to the left, up, or sorry, to the right, up, to the left, and down. Go ahead and draw that in. But notice here when I do my vertical line test, this fails, right? So even though this is an equation, it's not a function. So this fails. Oops. Today I can't spell fail. I'm spelling function. Fails, so not a function. And here, even though this is an equation, do you guys know how to graph that? No. Do I know how to graph that? Vaguely, because I've done math my whole life. But let me show you a website. This is what we call Wolfram Alpha. It knows all, it tells it all. And so here I can just, oh, I can't. I'm a liar. This isn't the PDF. This is I've raster sized it, if that makes any sense for anyone who's done this sort of stuff. So let's go ahead and type this in. X equals y cubed minus 3y squared. Hi. Why'd you not put in this? Okay, and so when you type in formulas, you're going to use little carets to do exponents. Oh, that's like what you guys do. Notice here, this looks like a function, right? But notice here, they put the x here and the y here. So let me redraw that for you guys correctly. I wish I could force it on the right one. What's the other graphing, guys? You guys all use a graphing thing. It's called, oh, what's it called? Desmos? Is that what it is? I think it's Desmos. Let me try Desmos real quick. Desmos. No, I think, yeah, there we are. Desmos. Hi, Desmos. The graphing calculator. No, that's not what I want. That's what I want. Let's try it here. X equals, oh, I lost what I was typing in. Y cubed minus 3y squared. There we go. That's a much easier for you guys to understand and see. So if you have trouble graphing something, go ahead and use this. My suggestion for something like this, obviously, I don't expect you to know it. You don't expect to know it. It's a good way to check your answers. No offense, you guys are going to be on a computer the whole time. Check your answers. Is it bad? Yeah, it is bad, right? But is it anything we can fix? No. And so I'm going to just put this right up here. Because you guys might get too used to not learning how to do things and just be able to use that. All right, so here's our function. I just kind of copied it down. Here we notice, we draw it here. It hits once, it hits twice, it hits the third time. So this fails and is not a function. I'm not horribly sad at that because you guys will all learn how to use technology really well, which is fine. You just may not learn how to do it by hand. And there's a reason it's nice to know how to do math by hand or stuff in your head. Memorization is a dying art because we can just look up anything on Wikipedia. And that's not always good because you can't have intuition about something that's not in your mind. And so you won't have the intuitive skills that come with mastery. Now, for you guys, you're going to have to be ever masters of math. No, you're probably just going to look it up every time. And that's fine. And I'm okay with that. So I just want you guys to be able to think mathematically by the end of this course. That way you can and know how to use the tools to solve math equations. And so at least when life confronts you, since 90% of you is never found without this in their pocket, charged phone in their pocket at that, most of you should be okay. All right.
I'm gonna be straight, Mr. May. Mr.
Yeah, go for it. So, yeah. So most of you will have it. So let's just get you through this class and move you on. All right. So let's do the next part right here. So we're going to define a relation. All right, so a relationship is a correspondence between the first set, which is called the domain, and the second set, called the range. Is just each member of the domain corresponds to at least one member of the range. And so this is more vague, a lot more vague. Let me see where it is. Let me see. This should not say, this should say this relations you see in your lives. And so you can list some relationships that you see in your life. And so this is things like I can write down actors' names, like, Tom Hanks. And then I can have movies on this side, like, Sleepless in Seattle. And then what's another Tom Hanks movie? Castaway. And so Tom Hanks goes to both of these movies, and then I can have another, Joe and the Volcano. And then was it Meg Ryan that's in like half of Tom Hanks movies? And so she'll go to two of them as well, but she's not in Castaway. And so that's a relation. So it's a little bit more loose, like your schedule. Like every one of you go to different time slots, but you go to multiple time slots. And so your schedule is a relation. I have definition of relation twice. Ignore this. That should have what a domain is. So here we want to find the domain for the following. And here I want to show how, in this case, everything is okay. Everything here for polynomials, all real numbers work. Okay. But notice here that we can't divide by 0. So one of the things we're not allowed to do is divide by 0. So dividing by 0 is bad. Divide by 0 is bad. So we can't do that. And so we have to figure out which values of these gives us 0. And we'd have to throw those out of the domain. So how do we do this? Well, we just solve this for 0. Equal to 0. You may or may not know how to factor very well right now. Remember, you just take multiples of this, and you take multiples of this number, so minus 4. I lied. Hold on. I'm backwards. You take multiples of this number, which add up to be this number. So we're going to take 5. This factor? Hold on. I'm at brain fire for a second. This may not factor nicely. I might just be, I may have typed this in wrong. Hold on. If I did, we'll just switch it right here. I'll leave the page. I think I swapped the numbers. Every now and then I do swap numbers. Yes, I swapped the numbers. Oh boy. Let's try it this way. This one, hold on. We're going to do x squared plus 5x plus 4 on the bottom. The other one gives you imaginary numbers. So we'll just go ahead and erase this out. So just change that on your paper. I write these notes and I check them, but some days if my dyslexia is bad, I don't check them perfectly. So here if I have x squared plus 5x plus 4, and so what we're going to do is we're going to take multiples of the one without the x. So here I have 4. So in order to get 4, I can use 4 and 1, or negative 4 and negative 1. Well, 4 and 1 add up to be 5. And so this is what we're going to be using. So we'll have x plus 4, x plus 1, and that's going to equal to 0. And that means x is either, that means x plus 4. We're using the 0 multiplication rule. It was either 0 or x plus 1 is equal to 0. In that case, x plus 4 equals 0. That means x is negative 4. Or x is negative 1. Because you just move the 4 over. So minus 4 to both sides. Minus 1, we get the following answers. So for the domain, either of these two answers gives us the division to be 0. So like me actually, on Photoshop, I got more power than this. Let's go and swap this. Ta-da! Make that all white. Just get rid of that, and then switch back to this, and we'll just write in what I want. X squared plus 5x plus 4. So notice here that either of these values will give you 0 on the bottom, which you're not allowed to do. And so we're going to say the domain is everything but this. And so it's going to be from minus infinity to negative 4, union minus 4 to 2, or not to 2, to negative 1, union all the way to negative 1 to infinity. So that's what the domain is. So the problems you'll see are polynomials. If you see a polynomial, your domain's everything. Okay, so if it's a rational, this is what we call this, is a rational function where we have a polynomial over a polynomial. If the polynomial on the bottom, or the expression on the bottom, is 0, we have to throw away all the points where it's 0 because we're not allowed to do that. We're not allowed to divide by 0. There's lots of reasons, we won't get into them. The other thing is let's look at the graph of this function. Now, have we figured out how to graph this function? Not quite yet, but we can always use Desmos to do that for us. So let's go back to Desmos real quick. So these are two functions you do not know how to graph yet, but you can use your little graphing calculator. So let's just type it in. So it'd be SQRT. Yep, that brings up what I want. That's fine. All right, so let's look at this. All right, so what is the domain? So when you look at a graph, the domain is all the values which of x I'm allowed to put in, right? And so here it looks like at negative 4 onward, I can put in values. Anything beyond that, I don't have anything. See, if I zoom way out, I don't see anything. So I'm not allowed to put in anything here. Why that is because you can't take the square root of a negative number. And so if x is negative 4, this ends up being 0, and so you're okay. But everything above that, everything above negative 4 is okay because of a value, but everything below that I don't. So the domain is which values of x. So what you need to get from this is when you look at a graph, can you say what the domain is? Can you say what the range is? Okay. I'll probably pull up some of the homeworks after this and kind of go through it a little bit with you. All right, so here, let's draw this in. So here at negative 4, you come here, and then it comes up like this. So notice here, for square roots, we want this value to be 0 or higher. And so one way to solve that is we just set x plus 4 equal to 0. That means x equals minus 4. So we need to be always above this. And so the domain is from minus 4 to infinity. What's the range? The range is all values of y, which I can achieve, right? Well, here, I can get 0, and I can get any number above that. And so the range here is from 0 to infinity. So that's the values of y. Let's look at this one. Do you know how to graph this? No, you don't know how to graph this, but you do have Desmos. I think the homework just gives you these graphs, if I'm not mistaken. Hi, so let's just type this one in. So here we'll have x to the 4th minus 2x squared minus 3. All right, and just go back, zoom back in. All right, so here's our graph. All right, so what is the domain for this one? See if someone can answer that. What's the domain of this graph? And once you get the answer, go ahead and just put it into chat. What's the domain here? And remember, the domain asks which values of x am I allowed to use? Or what are the input? Sorry, that's range. Yeah, so Lexi has the range, right? So Lexi already stated what the range is. So the range is what values can I hit? Well, from -4 onward, right? Because no matter how much I zoom out, I can get any positive number I ever want, right? You'll eventually hit that, right? The domain here. So, but the domain here is, since this is a polynomial, right? This is just some sort of polynomial. So the domain is all real numbers, right? If I wanted to, I can plug in -552 into this, cube it or quart it, and then square it, and you still get a number. So this is all reals. And the range is from, we can't hit -4, so it's from -4 to infinity. And if I do this in, hold on, I lost my little graph. Hi, camera graph back, please. Graph me, thank you. Let me draw this on the paper for you guys. Let me put it over here. So what's it? Oh, it's here. So here at 1, it's -4. So it's here, 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 here,